Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about the introduction to differentiation. Before we begin, if you are new around here, make sure you subscribe to our channel and press that notification button so that you will be informed when we upload a new video on biology, chemistry, mathematics, and physics. So let's begin. So how do we differentiate a function? So assuming we have a function of the form y is equal to what? X raised to the power n, and we want to differentiate this function where n is what? It's a real number, either a positive or negative integer or even a fraction. There is a way we go that will help us to differentiate this. So by differentiating this, we add what? D to the y to make it the differentiation of what? Y. And because we are differentiating with respect to x, it becomes what? Dy dx. Now, once we apply dy dx to this function, it means we are differentiating the function y with respect to what? X. And then this is how it goes. We use the power over here to multiply the coefficient what? Of x, and then we subtract 1 from the power. By that, it becomes what? The power now comes down. We have n multiplied by what? X raised to the power n minus 1. So we use the power to multiply the coefficient of x, and then we subtract 1 from the power, and that becomes what? Our differentiation of the function above. So let's look at an example. Assuming we have the example y equals what? X raised to the power 4, and we are to differentiate this function. It means we need to apply the differentiation sign. That becomes what? Dy, and we are differentiating with respect to x, so dy dx is equal to, now the power is 4, so the 4 now multiplies the coefficient of x, so that becomes 4. The coefficient of x is 1, so it's still 4. Then x raised to the power what? 4, then we subtract 1 from it. So it means our dy dx becomes what? 4x cubed as the differentiation of the function x raised to the power 4. Alright, so let's have a look at another function. Assuming we have the function of the form y is equal to c, where c is a constant. It's a constant. If we differentiate this function, our dy dx becomes what? 0. So it means if we differentiate a function that is a constant, we get 0, or the derivative of any constant is 0. So let's have a look at an example. So assuming we have the example y is equal to 4, and we are to differentiate this function. Because we are differentiating with respect to x, it means the equation y is equal to 4 here has what? X raised to the power 0. And because we know x raised to the power 0 is 1, or any number raised to the power 0 is 1, it means this is what? X power 0 is 1. And therefore 4 multiplied by 1 is still 4. So that is how come we have the equation y is equal to 4. So with this, we can now go ahead and differentiate. So our dy dx becomes what? We use the 0 to multiply the 4, then we subtract 1 from it. So we have 0 multiplied by 4, x power 0 minus 1. Then our dy dx becomes what? Because this is 0 multiplying this over here, okay? Any number multiplied by 0 is what? Is 0. So it means if we differentiate a constant, we get what? 0. So let's have a look at another scenario. So assuming we have the function y is equal to what? Ax, where what? A is a constant. Now if we have this, okay, it means if we differentiate this function, our dy dx becomes what? Just what? A over here. Okay, so how is that so? Because the function over here, the x has the power what? 1. If we differentiate this, let me do that one by one so that you can see. So we have our y is equal to what? Ax. If we differentiate this, our dy dx becomes what? The power over here is 1. So 1 multiplied by a, so we get 1 multiplied by a power x raised to the power 1 minus what? 1. So we have our dy dx becoming what? 1 multiplied by a is still a, x raised to the power 0. And we know x raised to the power 0 is what? 1. So finally, our dy dx is equal to what? The constant a. So let's look at what? An example of this. So if we have the example y is equal to -7, y is equal to what? -7 x, and we have to find what the differentiation, or we have to differentiate this function. How do we go about that? So first of all, if we differentiate this function, we get what? Our dy dx to be equal to what? Because the x over here has the power 1, we use that 1 to multiply the -7. So we have +1 multiplied by -7. Then the x comes here, power 1 minus 1. So we have our dy dx becoming 1 multiplied by -7 is -7. Then we have our x raised to the power 0. And then we know what? Our dy dx becomes what? -7. Any number raised to the power 0 is 1. So we have 1 here. So finally, our dy dx is equal to what? -7. Alright. So let's continue. Now, we want to have another scenario. So assuming we have the function or function of the form y is equal to what? The function f of x plus the function g of x, then minus the function h of x. Okay, how do we differentiate this function? Okay, so if we differentiate the function y, it means we are applying what? Dy dx to this, which is equal to what? D dx of the entire function over here, that is what? F of x plus g of x minus what? H of x. Okay, now when we are differentiating individual functions that are what? That are put together by addition or what? Subtraction sign, we can differentiate the individual functions one by one, and then we add all of them together to get the overall differentiation of the function. By this I mean what? Our dy dx now becomes what? D dx of the function what? Of the function what? F of x, then plus d dx, that is the differentiation of this particular function g of what? X alone, then minus the differentiation of what? The function, the third function, that is what? H of what? X. So it means once we differentiate each of the functions individually, we can now add all of them to get our overall differentiation of the function. So let's look at an example. So assuming we have the example y is equal to what? X raised to the power 5 plus 1 minus x minus 4x, and we have to find what? Find dy dx of the function, which means we have to differentiate this function. How do we what? Solve this function? So first of all, if we differentiate this function, let me rewrite this function in a form that we can simply what? Differentiate. So we have y to be equal to x power 5 plus 1 over x becomes what? X inverse, or x raised to the power -1. Then we have minus 4x over here. So from here we can easily differentiate the function. So our dy over dx becomes what? D dx of the function what? X power 5 plus x inverse minus 4x. Okay, so from here we have what? Our dy dx to be equal to what? The differentiation of each of the individual functions in the bracket, that is x power 5 plus d dx of the function x inverse minus d dx of what? 4x. This is 4x because the negative is already outside. So it means our dy dx becomes, now we can differentiate this function individually. Okay, so now if we differentiate x raised to the power 5, it means we use the power 5 to multiply the coefficient, which is 1, then we subtract 1 from the power. So we have what? 5 multiplied by what? X power 5 minus 1, then plus, then this function. So this, we have -1 as the power, so we have -1, we multiply this, then x power 1, then we subtract 1 from the power again, then minus, this is 4x, the x has the power 1, so we use 1 to multiply the 4, then x raised to the power what? 1 minus 1. Alright, so it means our dy dx of this function becomes what? 5x power 4 over here, then this becomes minus what? X raised to the power -2, then we have what? Minus 4x raised to the power 0 over here. So from here we know our dy dx becomes what? 5x power 4 minus what? S negative squared, then minus what? 4. From here we can rewrite this in a more beautiful way, that is 5 power 4 x power 4 minus what? 1 over what? S squared minus 4. So this is the answer that we obtain after we differentiate the function what? X power 5 plus 1 over x minus 4x. Alright, so let's have a look at another example. So we are to differentiate the function y is equal to what? 4x cubed minus 3s squared plus what? 5 on what? S squared. Alright, so let's look at the solution for this example. Solution. So let me rewrite the entire function in a more suitable way. So we have y is equal to 4s cubed minus 3s squared plus 5x negative squared. Okay, so we brought the s squared over here to the top. So if we differentiate this function, it means we are applying dy dx, that is what? D dx of the entire function that we have over here, that is 4x cubed minus 3s squared plus 5x negative squared. So it means our dy dx becomes the differentiation of all the individual functions we have in the bracket. So we have d dx of the function 4x cubed minus d dx of what? 3s squared, then plus d dx of what? 5s negative squared. So our dy dx becomes, now if you like, because 4 is a constant, you can bring it outside or in front of the d dx, then you just differentiate what? S cubed, and then you use it to multiply, and then you continue, or you can continue ahead. Okay, so for the sake of this tutorial, let me bring the constants that are just the numbers outside. So this becomes 4 d dx of the function what? S cubed, then minus what? The 3 will also come outside, 3 d dx of what? S squared, then plus, I bring the 5 outside. Oh, let me erase that. Alright, so 5 outside, d dx of the function x negative squared. So from here, let me continue here. Our dy dx becomes what? We now have this 4 over here. We still have it over here. Then we differentiate this function. Now if we differentiate what? S cubed, it becomes what? The 3 comes and multiply the x. So we have 3x raised to the power 3 minus 1. Then we have minus the 3 that we have over here. We still have that one here. And then into bracket, if we differentiate what? S squared, we get what? The 2 comes and multiply the x squared. Then we subtract 1 from the power. So this becomes what? 2x raised to the power 2 minus 1. Then plus the initial 5 that we have over here. I'm writing it here. Then we have what? This becomes what? Negative 2 multiplied. This becomes negative 2x, negative 2 minus 1. So let me rewrite all of this so that we can see it very well. So I'm rewriting everything over here. So we have 4 into bracket 3s. Let me simplify this. This becomes squared, then minus 3 into bracket 2x. This becomes just 1. Then plus 5 into bracket negative 2x. This becomes what? Negative 3 over here. So from here we can just simply do the multiplication, and then we get our answer. So we get 4 multiplied by 3, we get 12s squared, then minus 6x. Then this becomes what? Minus 5 multiplied by negative 2 becomes negative 10 x raised to the power negative 3. So from here we can simply just what? Rewrite this equation in a nicer way, and then we get our solution. So our dy dx becomes what? 12x squared minus 6x minus 10 on x raised to the power what? Cube. Okay, so this becomes our solution, our differentiation after we differentiate the function what? 4s cubed minus 3s squared plus 5 on what? S squared. The product rule. So let's look at this scenario. Assuming we have a function of the form y is equal to what? U and v, where both u and v are what? Are functions of x, are functions of what? Of the variable x. Okay, when this is the case, we need to use a rule that we call the product rule. So by u and v being the functions of x, I mean, let's say u is equal to what? A function, let's say s squared plus 4, and then v is a function, let's say s cubed minus what? Let's say 5. Okay, so it means our function y becomes what? A function of the form what? S squared plus 4, and then what? S cubed minus 5. Okay, if we look at this function over here, we can see that we have a function multiplying another function. So we have two functions multiplying each other. So whenever we have two functions multiplying each other and we are to differentiate this function, we use what we call the product rule. And according to the product rule, our dy dx, or our differentiation, becomes what? V du dx plus u dv dx. What do I mean by this? That means, first of all, we hold down the second function, that is v, then we differentiate the first function, then we use them to multiply, then we add it to what? We hold down the first function and then we differentiate the second function. Let me take that again. First of all, we differentiate the first function and we use the second function to multiply. That is what we have over here, v du dx. Then plus, we hold down the first function and then we differentiate the second function, then we multiply them, and then we add all together to get what? Our product rule. So with this basic introduction to how to use the product rule, let's go ahead and try some few examples to actually appreciate how to use the product rule. So example number 1, we have to find dy dx of the function y is equal to what? 3s squared plus 1, then 5x minus 8. This is our first example. So let's write down our solution. So we have the function what? Y is equal to, in one bracket, or that is the first function, we have 3x squared plus 1. Then the second function, we have what? 5x minus 8. So because we know these are two different what? Functions, and they are multiplying each other, we need to use what? The product rule. Alright, so by the product rule, if you're using the product rule, it means our dy dx, okay, is of the form, then we quote the product rule formula, that is what? V du dx plus u dv dx. Okay, once we quote it, we now have to what? Make sure what? We find each of these individual variables that we quoted in the product rule, and then we can be able to what? To solve the function. So let's say to solve this, we say what? Let u be equal to what? The first function over here. So we have 3s squared plus 1, then v be what? The second function. So we have what? 5x minus 8. Now that we have this, we differentiate each of the function individually. So if we differentiate the first function, we are differentiating u with respect to x, so it becomes what? Du over dx. So our du dx becomes what? D dx of the function what? 3s squared plus 1. Okay, so we have du dx to be equal to, if we differentiate 3s squared, we get what? 2 now comes to multiply the 6, then we subtract 1 from the power. Sorry, 2, this power 2 here comes to multiply the 3, then we subtract 1 from the 2 over here, so it becomes what? 6x. Now this is a constant, so if we differentiate a constant, we get 0. Okay, so our du dx is what? 6x. Now let's differentiate the function what? V. So our dv dx becomes what? If we differentiate 5x, x has the power of 1, so 1 multiplied by 5 is still 5. Now if we subtract the 1, that is, we have 5, now the power is 1, so we have 1 multiplying the 5, then we have x power 1 minus 1. So our dv dx becomes what? 5 x raised to the power 0, and then this is what? Dv dx is equal to what? 5, because x power 0 is what? Is 1. So now that we have du over dx, then we have dv over dx, we now know what our u is, what our v is. We just go and then insert them into this formula, and then we get what? Our dy dx. So it means our dy dx for this example becomes what? V. Where is our v? This is our v. So we have what? 5x minus 8. Then our du dx is what? This is our du dx is 6x. So we have what? 6x over here. Then plus u. Where is our u? This is our u. So our u is what? 3s squared plus 1. Then we have what? Dv dx. Our dv dx is what? Is 5 over here. Alright, so now we can proceed and then find our dy dx. So our dy dx becomes what? 6 multiplied by what? 5 becomes what? This multiplied by this becomes what? 30s squared. Then minus 6 multiplied by 8, we get what? 48 what? X. Then plus we have 3 multiplied by what? 5, we get what? 15s squared. Then we have 5 multiplied by what? 1, then we have what? Plus 5 over here. So it means our dy dx becomes what? This is s squared, this is s squared. So we have what? 45s squared minus 48x plus 5. Okay, so it means when we differentiate the function that we have over here, this is the result that we get when we use what? The product rule. So let's look at the second example. So the second example is what? Y is equal to, we have 2s squared minus 1, then we have what? S squared plus 3. So looking at this straightforward, we know we are to use what? The product rule. So by the product rule, we say what? Let the first function be u, that is 2s squared minus 1. Then the second function be what? V, that is s squared plus 3. So we differentiate each of the individual functions. So our du dx, that is the differentiation of the first function, becomes what? If we differentiate 2s squared, we get what? 4x. We differentiate a constant, we get 0. So our du dx becomes 4x. If we differentiate v with respect to x, we get what? 2x. That is, the 2 multiplies the x, and then we subtract 1 from here, so it becomes 2x. This is a constant. We differentiate it, we get what? We get 0. So it becomes what? 2x. So from here we can now what? Quote our product rule. So from our product rule, dy dx is equal to what? V du dx plus u dv dx. So from here our dy dx is equal to, where is our v? This is our v. We have what? S squared plus 3. Then what? Our du dx is what? 4x over here. Then plus our u is what? 2s squared minus 1. Then our dv du is what? 2x over here. So from here we can just expand the bracket, and then we do our addition and subtractions, and then we get our final result. So we have 4 multiplied by what? S squared will give us what? 4x cubed. Then plus 4 multiplied by this will give us what? 12x. Then plus this and this will give us what? 4x cubed. Then minus what? 2x. So it means our dy dx is now equal to, we have s cubed over here, s cubed over here. So 4s cubed plus 4s cubed becomes what? 8s cubed. Then plus this is 12x, this is negative 2x, it becomes what? 10x. Okay, so if we differentiate this function and we use, that is, we use the product rule, this is our final result after differentiating the function above. Alright, so let's consider the case above. So assuming we have the function of the form y is equal to what? U on v, where both u and v are functions of x. So we have u and v being what? Functions of x. Whenever we have what? An equation of the form u on v, and then we are to differentiate this function. We use the quotient rule to differentiate this function. By u and v being functions of x, I mean, let's say u, for example, u is equal to what? Let's say s squared plus 4, and then what? V is equal to what? S cubed minus what? 4. Okay, so it means our function y becomes a function that looks like this. Our u is what? S squared plus 4, and then our v is what? S cubed minus 4. Okay, so whenever we have a function of this form and we have to differentiate this function and to find our dy on the x, we need to use what? The quotient rule to solve an example like this. Now, what says the quotient rule, or what is the quotient rule? So for the quotient rule, our dy dx is equal to what? V du dx minus u dv dx, all on what? V squared. So this is the quotient rule. So let me go through the rule with you. So our differentiation of the function y with respect to x, that is dy dx, is equal to, for the quotient rule, first of all, we hold down the denominator, okay, that is v, then we differentiate the numerator, then we multiply them, that is what? V du dx. Then we have minus, then we have what? We hold the numerator, that is u, then we differentiate the denominator, and then we multiply them. It becomes what? U dv dx. Then we divide all by what? The square of what? The denominator, which is what? V squared. And then that gives us what? The quotient rule. So this is the quotient rule, or the rule that we use to solve a problem of the form what? Y is equal to what? U on v, and this is an example. Alright, so now that we've know what the quotient rule is, let's now go ahead and use the rule to solve some few examples so that we can be comfortable with how to use the quotient rule. So the first example we want to look at is what? Y is equal to 2x plus 3 on what? X minus 5. Alright, so this is our first example. And to differentiate this, because we can see two functions and they are what? They are dividing each other, we need to use what? The quotient rule. Alright, so to use this, we have here our solution. So first of all, we say let u be the numerator we have over here, that is 2x plus 3. Then v be the denominator, that is what? X minus 5. Now we need to differentiate these two functions. So du, if we are differentiating u with respect to x, it becomes what? Du dx, and it's equal to, if we differentiate 2x plus 3, we differentiate 2x, we get what? 2. X, sorry, 3 is a constant over here, so we differentiate 3, we get what? 0. So du dx is now what? 2. Alright, if we differentiate v over here, we get dv dx is equal to, this is x, if we differentiate x, we get 1. And this is a constant, we differentiate a constant, we get 0. So it means our dv ds is equal to 1. Now we need to quote what? The quotient rule. And by quoting the quotient rule, our dy dx is equal to what? We have v du dx minus u dv dx all over what? V squared. So let's go ahead and substitute everything we have here into the formula, and then we can get our solution. So first of all, our du dx is what? Du dx is 2. So we have our dy dx is equal to du dx is what? 2. Then multiplied by v. V is what? X minus 5. Then minus what? Dv dx is what? 1. Then our u is what? 2x plus what? 3. Then all on our v is what? X minus 5. Then we square it, that is the v squared over here. So our dy dx now becomes, we multiply through, we get what? 2x minus 10. Then we have the negative 1 multiplied, this will give us negative 2x, then minus 3, all on what? X minus 5 squared. So our dy dx for this example becomes what? We have 2x over here, so they cancel each other. That is, this is positive, this is negative. So we have negative 10 here, negative 3. It becomes what? Negative 13 on what? X minus 5 all squared. So this is our answer after we differentiate the function 2x plus 3 on what? X minus 5 using the quotient rule. Alright, let's have a look at what? Another simple example. So example number 2, we have the function y is equal to what? S squared minus 1 all on what? 2s squared plus 1. Alright, so let's write down our solution. So as usual, we say let the numerator be the function u, that is what? S squared minus 1. Then the denominator be v, that is what? 2s squared plus 1. So we differentiate each of the functions individually. So we differentiate u with respect to x, we get what? Du dx, and it becomes what? If we differentiate s squared, we get what? 2x. We differentiate a constant, that is negative 1, we get 0. So du dx is what? 2x. If we differentiate v with respect to x, we get what? dv dx. And this, if we differentiate 2s squared, the 2 multiplies the 4, we get what? The 2 multiply the 2 over here, we get 4x. Then this is power 2 minus 1 becomes 1, so we get 4x. Then this is plus 1. If we differentiate 1, we get what? 0. So our dv ds is equal to what? 4x. So from here, we can go ahead and quote our quotient rule. So our quotient rule giving us what? dy ds is equal to what? v du dx minus u dv dx all over what? V squared. So it means our dy dx for this example is equal to, our v is what? 2s squared plus 1. So we have here 2s squared plus 1. Then our du dx is what? 2x. So we have 2x over here. Then minus our u is what? S squared minus 1. Then our dv dx is what? 4x. Then all on v squared. This is our v squared, so we have 2s squared plus 1 all squared. So we now have to simplify. So if we multiply through, we get 2x multiplied by 2s squared, we get what? 4s cubed. Then plus this multiplied by this, we get 2x. Then we have minus 4s cubed, this multiplied by this, then we get what? Plus 4x over here. Alright, all on 2s squared plus 1 all squared. So our dy dx becomes 4x. We have positive 4s cubed over here, we have negative over here, so they both cancel out. So we have 2x now plus what? 4x, and this becomes what? 6x on what? 2s squared plus 1 all squared. So this is the solution for the problem s squared minus 1 on what? 2s squared plus 1, if we are to differentiate this function and we use what? The quotient rule. So for us to be able to use the chain rule, let's look at this scenario. Assuming we have a function y is equal to u, or we say y is a function of u, and then u is also a function of x. For us to be able to differentiate these two functions, we need to use what? The chain rule. That is to say, y is a function of u, and then u is a function of what? X. So it means y is a function of a function. Alright, so if you want to find dy dx, or you want to differentiate these two functions, it means we need to use the chain rule, which is given to us by what? First of all, we need to differentiate the function y with respect to u. Then we get what? dy over du. Then we multiply it by what? By the differentiation of the second function, which is what? Du over dx. So we can see that from here du will cancel this, and then we have dy dx. So by differentiating each of these functions individually and multiplying them, we can get what? The differentiation of both of the functions given to us. Alright, let's look at an example. So assuming we have a function of the form y is equal to what? Ax plus b raised to the power n, and we have to find what? Dy dx. Dy dx of this function. Dy dx will be given to us by, so this, first of all, we differentiate this function just as a whole, and then secondly we differentiate what we have in the bracket over here. By that I mean, first of all, we differentiate everything over here. By that we use the n, which is the power, to multiply the whole function, and then we subtract 1 from it, so it becomes what? N multiplied by what? Ax plus b. Then we have n minus 1. That is what differentiated the entire function. Then we multiply that by what? The differentiation of what is in the bracket. That is what? D dx of the function in the bracket, that is ax plus b. So this is also the same as what? The chain rule that I've given over here. So by this we can see that the dy over du, for example, is just the differentiation of the entire function, and then u being a function of x is what is in the bracket, and then the differentiation of that is what we have over here as du over dx. So let's have a look at how these questions normally look like and how we can use the chain rule to solve them. Alright, so assuming we have an example over here. Example, we have y is equal to 3x plus 4 raised to the power 5, and we have to differentiate this function. How do we go ahead to solve such a problem? So first of all, we say what? Let the function within the bracket be u. So u is equal to what? 3x plus 4. If u is equal to 3x plus 4, it means the equation we have over here at the top can be rewritten as what? Y is equal to what? U raised to the power 5, because u is now 3x plus 4. So we can see now that what? U is a function of x, and then y is a function of u, as the example that we've given over here. So hence we can use the chain rule to solve this example. So from there we know what? The chain rule says that what? Dy dx is equal to what? The product of what? Dy over du multiplied by what? Du over what? Dx, which means we need to differentiate, or we need to find what? Dy over du. So for us to find dy over du, we need to differentiate this function over here. So by differentiating this function, we get what? Dy over du is now equal to, this is u raised to the power 5. So if we differentiate this function, we use the 5 to multiply the u, and then we subtract 1 from the power. So it becomes what? 5 multiplied by what? U raised to the power 5 minus 1. And this is equal to what? 5u raised to the power 4. Now that we have dy over du, we need to differentiate the first equation that we have over here, that is what? Du over dx. So for us to get our du over dx, this is du, sorry, du over dx is equal to, we have 3x plus 4. If we differentiate 3x, we get what? 3. And if we differentiate 4, we get 0. So it is what? Still 3. Alright, so it means from here our dy dx of this function is equal to what? Dy over du is what? 5u power 4. Then multiplied by what? Du over dx is 3. So it means dy dx is equal to 3 multiplied by 5 is what? 15u power 4. So our dy dx finally is equal to, but we said initially that what? U is equal to what? That is, u is equal to what? 3x plus 4. So if we substitute this back, we get what? 15 into bracket 3x plus 4 raised to the power 4 as the differentiation of this example. So here is the trick. So if, let's say you have a similar question and you want to solve it easily, this is what you can do. You can first of all differentiate this entire function. That is, let me use another color for that. Let me use blue. Alright, so first of all, you can differentiate this entire function as a unit. So if we differentiate everything over here, it will become what? 5 raised to the 5 multiplied by what? 3x plus 4, then power 4 over here. Okay, so that is, we are differentiating everything over here. So we use the 5 to multiply the bracket, and then we subtract 1. Then we differentiate what is in the bracket. Okay, so if we differentiate 3x plus 4, we get what? 3. So from here directly you can know that what? 3 multiplied by this will give us what? 15, then we have 3x plus 4 raised to the power 4 as our final answer. So you can use this as a shortcut to get your answer, so that in case you are done with the work and it doesn't tally, you know that what you've done a mistake or you've done an error somewhere. Alright, so let's proceed and look and solve few more examples so that you can appreciate what we are doing. Alright, so let's look at an example. So the first example we want to look at is what? Y is equal to what? 2s squared minus 5x squared. So if we are to differentiate this function, we know straight ahead we are to use what? The chain rule. So first of all, we say what? Let u be equal to what? 2s squared minus what? 5x over here. So it means the function y is now equal to what? U squared. So if we differentiate u with respect to what? X, we get what? Du dx, and that will be equal to what? If we differentiate 2s squared, we get what? 4x. We differentiate 5x, we get what? 5. So it means our du dx is equal to what? 4x minus 5. Alright, if we differentiate dy, that is y with respect to u, we get dy du, and this will be equal to what? 2u. So that means what? Our dy dx, or our chain rule, dy dx is equal to what? Du dx multiplied by what? Dy du. So from here, our dy dx is equal to the product of what? 2u and what? 4x minus 5. Alright, but we know that what? But we know u is what? 2s squared minus 5x. So if we do the substitution, we get what? 2 into bracket 2s squared minus 5x, then multiply by what? 4x minus 5. Alright, so all we need to do from here is just to expand the bracket and then get our answer. So our dy dx becomes what? This multiplied by this will give us what? 4x squared minus what? 10x, then multiplied by what? 4x minus 5. So our dy dx is equal to, from here we just use we just multiply through everything over here. So we have 4x squared multiplied by 4x, so we get what? 16x cubed. So 4x squared multiplied by 5, we get what? Negative 5, sorry, we get negative 20x squared. So we have negative 10 multiplied by what? 4x, we get what? Negative 40x squared. Then we have negative 10 multiplied by what? Negative 5, we get what? Positive 50x. So our dy dx is equal to, this is negative 2x, negative 20x squared, negative 40x squared. So we have 16x cubed minus what? 60x squared plus what? 50x as our answer for differentiating this function above. Alright, let's look at another example. So the second example is what? Y is equal to what? 3x plus 1 raised to the power 7. So we know how this goes. We said let u be the function over here, that is 3x plus 1, and then that means our u is now what? Our y is now what? U raised to the power 7. Then we know the chain rule says what? Dy dx is equal to what? Du dx multiplied by what? Dy du. That means what? We need to differentiate this. If we differentiate u with respect to x over here, we get what? Du dx, and that is equal to, we differentiate 3x plus 1, we get what? Just 3. Then we differentiate this, so we have dy du. If we differentiate u power 7, we get what? 7u power 6. That is, we use the 7 to multiply the u, then we subtract 1 from the power. So from here we know that our dy dx is just the product of these two values. So we have 3 multiplied by 7u power 6. So it means dy dx is equal to what? 21u power 6. Bet what? U. So from here we know bet u is equal to what? 3x plus 1. So it means our dy dx is equal to what? 21 into bracket 3x plus 1 all raised to the power 6 as the differentiation for the second example. So let's have a look at one final example and then we end this tutorial. All right, so the third example we want to look at is what y is equal to 3x power 4 minus 5 or is the power 7. All right, so we say let what is in the bracket be used. So we have 3x power 4 minus 5. So it means y is equal to what? U power 7. That is replacing everything over here with the u that we said let it be over here. All right, so as usual we know dy dx is the product of what? Du dx multiplied by what? Dy du. So let's differentiate the first one. We differentiate du with respect to what? X. We get du dx, and then if we differentiate this, we use the 4 to multiply the 3. We get 12x power what? 3. Then minus 5, we differentiate that is 0, so it's still what? 12x cubed. Then our dy du is equal to what? 7u power 6. That is differentiating y is equal to what? U raised to the power 7. So from here we know that our dy dx is equal to 12x cubed multiplied by what? 7u power 6. All right, so from here we know dy dx, sorry, let me use this dy dx is equal to, if we do the multiplication, 12 multiplied by 7 will give us what? 84. So we have 84s cubed multiplied by what? U power 6. So just do the substitution. We have 84s cubed. Then we know that u is what we have over here. So multiplied by what? 3x power 4 minus 5 all raised to the power 6 as our final answer. So assuming we have a function, let me use a blue color. Assuming we have a function of the form y is equal to x on x minus 2 then x minus 3. So this is our function, and we have to what? Find dy dx, or we have to differentiate this function. How do we go around differentiating such a function? Now if you look at this function very well, we can see that these two functions are dividing each other. So normally the idea of using what? The quotient rule would come to mind, but this is wrong, because this is wrong in the sense that these are not just what? Two functions dividing each other, but then at the denominator we have what? A product of what? Two functions. Okay, so this is what? In a rational form. Okay, so we cannot use the quotient rule to differentiate this function. So if we definitely want to differentiate this function, we need to what? Convert it into what? Partial fraction. Okay, so once we are able to convert partial fraction, all right, so let's have a look at how we go around to differentiate this function using this as an example. So with this, let's just for now ignore the y over here. So to convert this rational function into partial fraction, we equate this to what? A certain equation. That is, we say what? X on what? X minus 2 then x minus 3 should be equivalent to, let's say, a variable a on what? X minus 2 then plus another variable b on what? X minus 3. So this is the process of what? Converting a rational function into what? A partial fraction. So from here we can see that the LCM for both sides is the product of these two functions at the bottom over here. So we have the LCM as what? X minus 2 then x minus 3. So this will go here, 1 multiplied by x will still give us x is equal to x minus 2 will go here. Okay, we'll cancel this, leaving what? X minus 3. So we have the a multiplying by what? X minus 3, then plus this will come here, will cancel each other, leaving this. So this will come and multiply the b. So we have b multiplied by what? X minus 2. All right, so from here we need to find the values of what? A and b, so that we can solve the we can get the partial fraction. All right, so let's say let x be equal to what? Positive 3. Now when x is 3, we can see that 3 minus 3 over here will give us 0. So we have eliminated a, but then 3 minus 2 give us 1, so we still have b, so we can find x. X is equal to this. If x is equal to 3, then this means here will become what? 3 is equal to a into bracket 3 minus 3, then plus b into bracket 3 minus 2. So from here we have what? 3 is equal to 3 minus 3 is 0, so 0 multiplied by a is still 0, plus this is 3 minus 2, which is 1, so 1 multiplied by b is still b. So it therefore means our b is equal to what? 3. Now again, let's say let x be equal to what? If x is equal to what? Positive 2, we can see that here can also be what? Dealt with. So if that is the case, it means the x over here, we are still using this function to find both. So it means that x over here is now what? 2 is equal to a into bracket 2 minus 3, then plus b into bracket what? 2 minus 2. So we have 2 is equal to what? 2 minus 3 is negative 1 multiplied by a, so we get negative a, then plus what? 0b. This is still 0. So it means our a is equal to what? Negative 2. So it means at the long run, converting the rational function into a partial fraction, we have what? X over what? X minus 2, x minus 3 is equal to what? The a is negative 2, so we have negative 2 on what? X minus 2, plus b is what? 3 on what? X minus 3. Alright, so now that we have the function in a what? In a partial fraction form, we can now go ahead and differentiate what we have over here, okay, so that we get what? Our final answer as the differentiation of this function, since both of them are equal. Alright, so let's go ahead and differentiate that function. So it means our y is now equal to what? Negative 2 on what? X minus 2, plus what? 3 on what? X minus 3. So we are now going to what? Differentiate this function. Okay, so if we differentiate that function, we get dy dx to be equal to what? D dx, that is, we are differentiating the function negative 2 on what? X minus 2, then plus 3 on what? X minus 3. Alright, so our dy dx becomes the differentiation. It means we have to differentiate each of these functions individually, since they are what? Two functions what? Being brought together by what? The summation sign or the plus sign. So it means we will have to differentiate the first function, that is what? Negative 2 on what? X minus what? 2, then plus this as 1, plus d dx of what? The differentiation of what? 3 over what? X minus 3. Alright, so our dy dx is equal to, from here we can bring the negative 2 we have over here is a constant, or we can rewrite everything over here as what? Let me have this. So all that we have over here can be rewritten as what? Negative 2, then x minus 2 raised to the power negative 1. So we bring this to the top, so it becomes x minus 2 raised to the power negative 1. Then we do that for this side as well. So we have d dx into bracket 3 here, x minus 3 raised to the power negative 1. Then we bring this out, we close the bracket. Now our dy dx is now equal to, now the 2 over here is a constant, so when we are differentiating a function, we can bring the constant outside and then we differentiate just what we have over here. So we bring the negative 2 out, then we differentiate what we have over here, just x minus 2 is the power negative 1. Then we do the same thing over here, we have 3 outside, d dx of just what is inside over here, that is x minus 3 or is the power negative 1. Alright, so dy dx is now equal to what? Now we still have this negative 2 over here, that is over there. Now this function over here, just the x minus 2 is the power negative 1, looks like a certain function. Now in our previous tutorial we talked about what? How to differentiate, okay, how to differentiate a function using what? The chain rule. And this function looks like a function that needs us to use what? The chain rule. By the chain rule, it means we need to differentiate the entire function over here as 1, and then we differentiate what is in the bracket differently and we multiply all of them. Okay, that is how the chain rule works. So it means, first of all, if we are going to differentiate this, let me use another color to show that. Let me use green. So we use the -1 to multiply the entire function over here, so it becomes what? -1 multiplied by what? X minus 2. Okay, then we now differentiate the function that is just in the bracket. So if we differentiate x minus 2, we get what? Just 1, because if we differentiate x is 1, so that is what? 1, and we differentiate 2 is 0, so it's still 1 over here. Then plus this 3 is here, we have the 3. Then the same thing applies to this one. We need to use what? The chain rule to differentiate this. So we need to differentiate this as a whole, and then we differentiate what is just in the bracket. So we use the -1 to multiply everything over here, so it becomes -1 multiplied by what? X minus 3. Oh, sorry, if we differentiate this, we subtract 1 from the power, so here becomes -2. So the same thing over here, -2. Then we differentiate just what is in the bracket. So if we differentiate x minus 3, we get just what? 1. So it's still over here. So it means our dy dx is equal to what? -2 multiplied by what? -1 will give us what? +2 into bracket x minus 2 all raised to the power -2 and still multiplied by 1 is still +2. Then plus we have +3 multiplied by -1, that will give us what? -3 multiplied by +1 is still -3, so we have -3, then x minus 3 raised to the power what? -2. So from here our dy dx is equal to what? 2 on what? X minus 2 all squared, then minus 3 over what? X minus 3 squared. That is, I'm bringing this, okay, this under this because of the -2 over here. I'm also bringing this under this because of the -2 over here, and that is how come we have this as our answer. So in the long run, our dy dx, if we are to differentiate that partial fraction that we derived from solving the rational function, our final answer is going to be what? +2 on what? X minus 2 squared minus 3 on what? X minus 3 squared as our final answer. Alright, so now that we've dealt with the first example, let's look at other examples so that we can appreciate what we are doing. So let me use black for this example. So we are to differentiate the function y is equal to what? 2x on the function 2x minus 1, then what? X minus 3. Alright, so first of all we need to what? Convert this function into what? Into a partial fraction so that we can be able to what? Solve it easily. So in that case, this is equivalent to, let's say, a function a over what? 2x minus 1, then plus b on what? X minus 3. So from here we say what? The LCM is what? The product of these two functions. So 2x minus 1, then x minus 3. So it means this will go here, 1 multiplied by this is now 2x is equal to, this goes here, cancels this, leaving this. So we have a multiplied by what? X minus 3, then plus b. This will go here, will cancel this, leaving this. So this now comes and multiply the b. So we have 2x minus 1 over here. Alright, so from here what we need to do is just to what? Look through the equation and see if there is a way we can what? Simplify this equation and get the value of what? A and b. Now if we look at this, we can see that if we let x be what? +3, we can get rid of a and then we can find b easily. Okay, so from this equation, let me put a dot over here. Let's say what? Let what? X be what? +3. Now when x is 3, we have this becomes 2 into brackets 3 is equal to a into bracket 3 minus 3, then plus b into bracket 2 multiplied by what? 3 minus 1. Okay, so we get 6 is equal to, this is now nil, becomes 0. Then we have, this is what? 2 multiplied by 3 is 6, minus 1 is 5. So we have what? 5b. So from here we can make just what? B the substitute by dividing both sides by what? 5. So it means our b is equal to what? 6 on 5. All right, so now that we have b, let's see whether we can find the value of a. Now if we look at what we have over here, there's no way we can get b from here easily. Okay, so it's either we expand this whole equation so that we'll be able to what? Solve it like a simultaneous equation and get the value of what? A. So doing that, let's expand this entire function that we have over here. So let me use another color for that. Let me use deep blue over here. So we have the 2x from here is equal to, we multiply through, we get ax minus what? 3a. Then plus, we do this, we get 2bx minus what? B. Alright, so it means we have 2x is equal to, we have x over here, so we group them. Okay, so we have what? If we have this, then plus 2bx, then minus 3a minus b. So it means 2x is equal to, if we factor out the x, we have x a plus what? 2b, then minus 3a minus b. So from here, if we compare coefficients, okay, we can see that here has what? An x multiplying it, here also has an x. So it means we can equate the two of them. So we can say what? A plus what? 2b, sorry, this is 2b is equal to what? 2 over here. But we know that b is what? 6 on 5. So we can do the substitution and get the value of a. So it means our a is now equal to 2 minus what? 2 into bracket. The b is 6 on 5. So if we punch everything here into the calculator, we are going to get negative 2 on 5. So it means if we convert this rational function into a partial fraction, this is what we are going to get. We are going to get this 2x on what? 2x minus 1, x minus 3, to be equivalent to the function our a is now negative 2 on 5. So we have negative 2 on 5 multiplied by what? 2x minus 1. Then plus the b is what? 6 on 5 multiplied by what? 3 minus, x minus 3. Alright, so it means in the long run, our y is equal to this function over here. So we have negative 2 on what? 5 multiplied by 2x minus 1, then plus 6 on what? 5x minus 3. So from here, we can now differentiate this function and get what? Our final answer. Alright, so if we are to differentiate the function, that is this function over here, this is what we get. So we have our dy dx now being equal to d dx of the function negative 2 on what? 5, that is 2x minus 1, plus 6 on what? 5x minus 3. Okay, so let's quickly solve this. So our dy dx is now equal to what? d dx of the function negative 2 on 5, 2x minus 1, okay, then plus d dx of the function 6 on 5 multiplied by what? X minus 3. Okay, so our dy dx is now equal to, we can rewrite this entire function as what? D dx of what? Negative 2 on 5 multiplied by what? 2x minus 1. That is, this is a fraction and we are bringing this to the top, so raise the power negative 1. Okay, so we close the bracket. Then the same thing applies to the second one. We have d dx. Now this is what? 6 on 5, so we have 6 on 5 multiplied by what? What we have over here coming at the top becomes what? X minus 3 raised to the power negative 1. This is 3. Alright, so from here we know that this are just constant, so we can bring them outside and just differentiate what we have in the bracket. So we have dy dx is equal to what? Negative 2 on 5 d dx of the function just 2x minus 1 inverse plus 6 on 5 then d dx of the function x minus 3 inverse. Now, like I said earlier on when we were solving the first example, to differentiate a function that looks like this and has a power, we need to use what? The chain rule. And by using the chain rule, it means we differentiate this as a whole, then we differentiate what we have in the bracket as well. So it means our dy dx for this example is, we still have the constant negative 2 on 5. Let me use another color for the rest. So let me use deeper blue or violet. So if I am to differentiate this function, first of all I need to differentiate it as a whole. So it means the negative 1 will come and multiply the entire function, then we subtract minus 1 from here. So we have negative 1 multiplied by what? 2x minus 1. Then if we subtract minus 1 from this, we get what? Negative 2. Then we now multiply by what? Differentiation of what we have in the bracket over here. So if we differentiate 2x minus 1, we get what? Just 2. Okay, then plus we still have our constant 6 on 5. Then if we differentiate this, it goes the same way. So the negative 1 comes and multiply this. So we have negative 1 here multiplied by what? X minus 3 raised to the power negative squared. Then we differentiate what we have in the bracket, which is what? Just 1, because if we differentiate just x, we get 1, and this is a constant, so it becomes 0. So from here it means our dy dx is just what? The multiplication of everything that we have over here. So if we multiply 2 by 1, negative 1, we get what? Negative 2. So negative 2 multiplied by 2 on 5, we get what? Positive 4 on 5 multiplied by what? 2x minus 1 raised to the power negative 2. Then plus 1 multiplied by negative 1 is what? Negative 1 multiplied by 6 on 5 is what? Negative 6 on 5. So we have negative 6 on 5. Then x minus 3 raised to the power negative squared. So finally our dy dx is now equal to what? 4 on 5 multiplied by what? If we change this, multiplied by what? 1 over what? 2x minus 1 all squared. Then plus negative 6 on 5 multiplied by what? 1 over what? X minus 3 squared. So our dy dx, that is, we are rewriting this in a more suitable way, will become what? 4 on what? 5 into bracket 2x minus 1 all squared, then minus 6 on what? 5 x minus what? 3 squared as our final answer for differentiating example number 2. Okay, so let's have a look at what? One final example, and then we end this beautiful tutorial. So the last example we want to look at for this tutorial is what? Y is equal to what? 3x minus 1 on what? X plus 2 what? 2x minus 1. Now because I've gone through how to solve how to convert this into what? A partial fraction twice, I believe you could do that. So I'm just going to write the result after what? Converting this into a partial fraction, and I expect you to be able to what? Do the conversion yourself, so that you can keep the tutorial as short as possible. So if you are able to what? Convert this rational function into a partial fraction, this is what you get. You get 7 on 5 multiplied by what? X plus 2, then plus 1 on what? 5 2x minus 1. This is the result that you get. So from here it means what? Our y is now equal to this function we have over here, that is what? The function 7 on 5 x plus 2 plus what? 1 on what? 5 2x minus 1. So if we are to differentiate this function, our dy dx now becomes what? d dx of this entire function, that is what? 7 on what? 5 this plus 1 on 5 2x minus 1. Okay, so if we expand the bracket, our dy dx becomes what? d dx of the function 7 on 5 x plus 2, okay, then plus d dx of the function 1 on 5 2x minus 1, and that is that. Okay, so from here we can bring dy dx here, then we have what? We can break the fraction outside, that is what? 7 on 5, then d dx of just what is left at the bottom over here, so which becomes what? X plus 2 raised to the power negative 1, then plus 1 over 5 what? D dx of the function 2x minus 1 inverse. Okay, so from here dy dx becomes what? We still maintain this, we have 7 on 5, then we differentiate this. So as usual we use the chain rule, so we use the negative 1 to multiply this, so it becomes negative 1 multiplied by what? X plus 2, then we subtract minus 1 from here, so it becomes negative 2. Then we now differentiate what is in the bracket, so if we differentiate x plus 2 we get what? Just 1, then plus 1 on 5, then we differentiate this, so it becomes negative 1 multiplied, so we have negative 1 multiplied by what? 2x minus 1, it now becomes power 2. If we differentiate 2x minus 1 we get what? 2. So it means our dy dx is now equal to what? If we use 1 to multiply negative 1 we get negative 1 multiplied by this, we get negative 7 on 5 into bracket x plus 2 negative what? Squared. Now plus, if we use 2 to multiply negative 1 we get negative 2 multiplied by this, we get what? Negative 2 on 5 multiplied by what? 2x minus 1 or to the power negative squared. Alright, so if we rewrite everything we have over here in a more suitable way, we get what? Our dy dx to be equal to what? Negative 7 on 5 into bracket x plus 2 squared, then plus negative 2 on 5 2x minus 1 all squared. So finally our dy dx for this example is what? Negative 7 on what? 5 x plus 2 squared, then minus 2 on what? 5 2x minus 1 all squared. So thank you so much for watching, and I will see you in the next video. Bye bye.